I had a question on the study packet for exam 3, question 7.5, chapter 7, number 5. And I should have probably had this triple starred, actually. It's a good question. It did have a typo in it that I've corrected, or it had a number of typos in it that I've corrected. I corrected them as of 1:30 p.m. Wednesday, November 8th. So here we go. The category 31 in that list from the text, the listed of estimated expenditures, prices, elasticities, price elasticity of demand. The demand for low-calorie milk products had price elastic demand, a demand estimate greater than 1. So we're going to use that category. Not the typo was that they had referred to category 30, high-calorie milk products that had a price elasticity of demand well below 1. It was price inelastic. So we'll actually do that one for number 4, but numbers 1 through 3 are written as though demand is elastic. The price elasticity of demand is estimated to be greater than 1. All right, so we're going to use the information in the table. I've got the table in the next slide. By what percentage would their demand fall based on the elasticity estimate, calculate the quantity they consume in grams before and after the price change, and then look at how total expenditure changes. The data comes from the table in the reading, and we're going to focus on these two categories down here. First on this category 31, where the price elasticity of demand is very, very high. Quantity demand is very responsive to changes in price. Category 30 we'll do after that, and that category is that's high-calorie milk products, and demand is very, very unresponsive to changes in price. Estimated elasticity of demand of 0.17, the lowest of the elasticity estimates reported in the table. All right, well, let's get to our calculations here. So let's look at category 31, low-calorie milk products. And the elasticity of demand is estimated to be 1.972. All right, well, what are we given? We're given that the original price is 0.15 cents for each 100 grams of low-calorie milk product. And we're also given that price goes up by 10%. So if we multiply the original price, 0.15, times 1.1, that's the original price plus 10%, we get 0.165 as the new price. Now, finding out the original quantity is a little bit trickier, just slightly tricky. They don't give us quantity in the table, but they do give us the total expenditure out of, I think, 100 is the normalized basket, but $1.44 of that $100, if I'm remembering correctly, was spent on low-calorie milk products. So, and if the price of each 100 grams was 15 cents, then I can divide the total expenditure by the price to get quantity. So when I do that, I get the initial quantity of 9.6. So that was, you had to do some work to get that. Not much work, but the relationship I'm working with is that total expenditure is equal to the price of the good times the quantity consumed. If I buy 10 pizzas at $20 a pizza, I'm spending $200 on pizza. All right, so what happens to quantity? Quantity, notice that the price elasticity of demand is 1.972. So quantity is going to, price goes up by 10%, quantity is going to go down for every 1% price increase, there's a 1.972% decline in quantity demanded. So if there's a 10% price increase, we're going to estimate that quantity demanded falls by 19.72%. Very, very big. And the way we figure out what the new quantity is to take 1 minus 0.1972 times the old quantity. So the old quantity is 9.6, and we're going to multiply that by 0.8207. Oh, what did I do to get? I made a mistake in my handwriting. 1 minus 0.1972 is 0.8208. And when I multiply those two together, I get the result that the new quantity is 7.71. And now as far as total expenditure, the new total expenditure, I have the new price is 0.165, and I'm multiplying that by the new quantity, 7.71, and I'm just going to do that in real time since I had a typo floating through my work before. I get total expenditure of 1.27. And notice that the initial expenditure was 1.44, now it's 1.27. Expenditure has fallen. When demand is price elastic, the revenue or expenditure effect follows the quantity effect, which is proportionally bigger. Remember that expenditures or revenues are price times quantity. Price is going up, quantity is going down. The effect on expenditures and revenues is ambiguous unless we know something about the price elasticity of demand. If demand is price elastic, it means the quantity effect is proportionally bigger. So the revenue effect, price times quantity, is going to follow the quantity effect. When the price elasticity of demand is less than 1, the demand is price inelastic, well then the expenditure effect is going to follow the price effect because the price effect is relatively bigger. That's what a price elasticity of demand that's less than 1 is telling us. The denominator, proportionate change in price, is bigger than the numerator, the proportionate change in quantity. Hence, the fraction is less than 1. All right, well, let's go on and do the same analysis now for category 30, which is price inelastic demand. Let's proceed. This is category 30. And this is high calorie milk. Oh boy, that's really bad handwriting even for me and my stylus. Milk products. And the estimated price elasticity of demand reported in the table is 0.1793. And we have that price has gone up by 10%. And so we'd expect quantity to go down by every 1% rise in price leads to a 0.1793% fall in quantity demanded. So a 10% rise in price, we're going to estimate that to lead to a 1.793% fall in the quantity demanded. So now we're going to do what we did before. The original price was equal to 0.09. That means the new price is going to be equal to 0.09 times 1.1, which is going to equal 0.099. The original quantity, again, I've got to back it out of the information on total expenditure. Consumers spent $2.32 of their $100 representative basket on high-calorie milk products, the price of each unit in that, the price of each 100-gram units of the high-calorie milk products was 0.09. So if I take total expenditure and divide it by the price per unit, I get quantity. My initial quantity by that calculation is 25.78 100-gram units of high-calorie milk products. All right, well, what's going to happen to quantity? Quantity, the new quantity, is going to be that old quantity, 25.78, less 1.793%. The way we get there is subtract from 1, we take 0.01793 away from 1, and I'm going to round a little bit here, but I take that original quantity and multiply by 0.9821. When I do that and round to 2 digits, I get 25.32. So quantity demand, it fell, but by relatively little for a 10% rise in price. And then we just, to tie things up in a nice little bow, let's calculate the new total expenditure. That'd be the new price times the new quantity, and that comes out to be 251. And in this case, the initial expenditure was 232. The new expenditure is 251. As expected, the total expenditure has risen. If it's a price inelastic demand, the expenditure and revenue effects follow the price effect.